also anyone joining tonight for the first time and not part of the WhatsApp group, please, I am going to add the link to the WhatsApp group to the chat, so that you can see it in the chat. And then one of the slides will also have my cell phone number that you guys can send a WhatsApp to me to add you to the group. Okay, so we will be looking at where is it? the second chapter tonight. So we're gonna look at functions and representation of functions. But let me just quickly, if you want to join the WhatsApp group, you can also use this number. And then if you want to email me anything, you can also email me. And then for the guys that still struggling to get into the Western Cape portal, you can send a copy or email to ctntat@unisa.ac.za so that they can give you access to the portal. Okay, so let's continue with tonight's session. We will look at the theory. There will be some questions that we will also look at. The session is recorded. It will be shared again on the Western Cape portal. I will share it on my side as well. So we will share the presentation afterwards and the recording. Okay, so we're looking at functions tonight. So merely looking at what a function is. Then we're going to look at linear functions. So linear function is basically a straight line function, but we'll get to that. We look at quadratic functions. So quadratic is normally a parabola. So we will look at examples of that. And then the two extreme ones, nearly exponential and log functions. Okay, so we look at all four of them. Obviously, the biggest focus, as in your assignments and exam, will also be on linear and quadratic functions. But we will add the other two and just look at that as well. Okay, so let's go into what is a function, specifically linear function. So how the linear function will look like, and we will get to a view of that. But a linear function is normally the y is equal to mx plus c. Then we will get that in some of it, there will be variables. So your x and your y will be variables. Your m, representing the slope, will be a number, and your c, representing the y cutoff, will also be a number. Then I think something that is important that might, if they ever asking a theory question, this is one of the definitions that is quite important. So one variable is dependent of a value of another variable. So we will always say that the dependent variable is a function of the independent variable. Okay, and we can nearly look at the dependent variable, sorry, x is a function of the independent variable y. So if one look at this formula, the x will be your dependent and your y will be your independent variable. Okay, so if I ask something like that as a theory question, then at least we have covered it. Then there's certain other things around functions that we will look at. So we will look at how to write that y equal to mx plus c. We will look at graphing it, but again, you won't need to graph something, but they might give you a function and ask which one of the graphs is representing the function. So remember, all your assignments and exam is multiple choice. So they can't ask you to draw something, but they can tell you or ask you which one of the following graphs is representative of a formula. And the last one in functions where we will go into is we will look at the Gaussian plane. So that is basically, we will look at the 4 quadrants. And in this instance, we will probably look at that you need to describe that point. So via a x and a y. And I'll just show how it will look in all of the 4 quadrants. Again, they might give you 2 or 3 numbers or points and ask in which quadrants it is. They might say which one is true or false, so or which one is incorrect. So there's a few ways that they can ask it. Again, they won't be able to say plot it, but they will be able to ask in a question which point represents a certain number. So that they can again ask in a question. Okay, so let's look at a first set of questions. So around straight lines, so around a function. It does not always need to be y is equal to mx plus c, so it might look a bit different. So here they tell you, so if we wanted to put it in a mx plus c, we could have done it so that you can just see the correspondence or how it looks in a different view. But here they talk about total cost. So again, you guys might have in any of your other subjects in DSC or in economics, and you might still, even this semester, do the economics part as well. So a lot of the questions that we will look at will nearly look at economics, where it looks at total cost or total revenue or profit or those kind of things. So they will always try to make it practical. So they will always try to link it back to one of the other subjects that you guys are also doing. So total cost in rand of renting a sailboat for N days is given by this function. Then they ask us to calculate the cost in rand to rent the sailboat for 1 day. Okay, so they're basically asking us if n is 1, how much will the total cost be? Okay, so they can ask you that n can be anything that they ask you. So they can say 10 days, 5 days, anything like that. It doesn't need to be 1 day. So they can ask you a question that they normally will ask is, instead of 1 day, is to say 1 week, so that you need to know that instead of n equal to 1, it will be 7 because there's 7 days in a week. So they might ask you it a bit differently, so that you first need to change the week to how many days, because the formula is in days. This instance, 1 day, so we just change the n. So it will be 6,500 plus the 4,125 times 1, because it is only 1 day. And that will be our answer to this question. So again, they can change that dependent variable, the number, to anything, which will then change your independent number. So in this instance, your final answer would have been, let me just check, 10,625. Okay, then question B, they ask a bit differently. So I'm nearly giving you a minute just to look at it, and then we can look at that. Okay, so in the second question, they phrase the question a bit different. So they ask us, Nick has 50,000 Rand cash available, and he wants to take his family on a sailing trip. How many days can he afford to rent the boat? Okay, so just slightly different. So now we know what the cost is of renting the sailboat. So the cost is the 55,000. There is the fixed cost of 6,500. Okay, let's quickly. Anybody else got issues with sound? Everybody else fine? Can you hear me? Thumbs up if you can hear me, else. Okay, so Neville, it might be that you just maybe disconnect and reconnect again, else it might be in the something else wrong. I am recording as well, so and we'll share the recording if the sound doesn't get on your side better. Okay, so we've got the 55,000, which is the total cost. We've got the 6,500. Then we've got the 4,125, but we will need to work out how many days. Okay, so first thing is to get rid of the 6,500. So we will subtract that from both sides. So then it is 55,000 minus 6,500, which gives us 48,500. And that we will need to divide by the 4125 to get us the number of days that you will be able to rent the boat. So 48500 divided by 4125 will give us 11 days 0.75 or 76. So he unfortunately won't be able to rent 12 days. So only 11 days you will be able to rent. So in the exam or in the assignments, they might. Okay, so let's quickly, why subtract? So I want to get rid of the 6500. So to get rid of it, I must subtract it on both sides. So on this side, 6500 minus 6500 will be equal to 0. So that I can isolate the n on the one side, but because I'm subtracting it on this side, I need to do the same on the left-hand side. Does that make sense? So what I do on the right-hand side, I must do on the left-hand side as well. Cool. Yeah, so it might be in the exam, and also be very careful for that. So he is not, because it's less than 12 days, he can't afford the 12 days. So they might in the exam be nasty and give you an 11, a 12. They might even give you 11.67 and a 10 as options to pick. Okay, so they ask us how many days. So you can't have 11.76 days. He does not or don't have the money to afford 12 days. So it will be then 11 days. So it's not like here where we can round up to the nearest number. It stays at the 11 days. Okay, I have the answers here for you as well, so that you can see it, and what you need to look at. So if I also ask you how many is left, they can ask that in a separate question. Okay, so I have added the answers for you guys as well. Okay, another one that they can ask. So again, it is around the functions. So they will give you information that you will need to write a function with. And then they can nearly ask in the next question, give you a bit of more information so that you can work out the function. So the same here is in the first one, they have given you the function. Now they want you to work out the function. So let's read what the question says. So a volleyball court has a rectangular shape. It has a width of x meters and a length of 2x. Draw a diagram of a court showing the dimensions. That, again, they will not do that in the exam. The reason why they want us to draw the diagram is so that you can see what will the formula be. Okay, so we've done in chapter 1, we've looked at formula for volume, for area, and for perimeter. So now they ask us, what is the area of a court? So the formula will be x times 2x. Okay, so, and then it might be, depending on your answer set, you might even simplify that you get 2 to the times x to the power of 2. Okay, so now we've used information from study unit 1, where they said in study unit 1, we've looked at perimeter, nearly adding all the sides. We looked at area where it's the one side times the other side, and we looked at volume. So in this instance, they ask us the area, which is the one side times the other side. Okay, so now we know that the area is 2x to the power of 2. So the next question, they will give you a bit more information to work out something. Okay, so here they tell us, suppose that the court has a width of 12 meters and that the whole area has to be repainted. Okay, so the width of 12 meters and the whole area has to be repainted. How much will it cost to repaint the court if the cost of paint and labor is 11 Rand 75 per square meter? Okay, so first thing that you will need to work out is how many square meters is this court. If we know that, we will multiply that by 11 Rand 75 to work out what the total cost will be of repainting it. Okay, so let's work out first the area. So we know that x is equal to 12. So 2 times x to the power of 2. So 12 to the power of 2 is 12 times 12, or 12 to the power of 2, which is 144. And then 144 times 2 gives you 288. Okay, so we know that the area now is 288. So then 288 square meters. So for 1 square meter, it is 11 Rand 75. So for 288, it will be 288 times 11.75. And that will be then your total cost of painting the court. So 288 times 11.75 is equal to 3384. Okay, so what they've done in this question is they started off with, you needed to work out what the area will be that you will need to cover with the paint. And then they said, okay, but after you worked out that total area, the cost to paint it is 11.75 per square meter. So the total will be that 288 times 11.75. Okay, so again, a bit different because they ask you first to work out nearly the area, then they ask you to work out the total cost. Okay, so again, I have added it in for you. So you can again go and re-look how it was calculated. They love to ask these type of questions. So they love to ask the questions that they give you information and you will need to look at it, and then you need to put the words into an equation. So they really love to do that. Okay, so let's look at the next component. And I think some guys are trying to log on and can't. I don't know if you miss some of it is down again. So hopefully more people will join during the session. But again, if you have trouble, you're falling off maybe in the session, don't worry. I am recording it so that I will share it later on in our WhatsApp group as well. Okay, so we first looked at the one part of linear functions. Now we're looking at the component where we have the equation of a linear function. We might look at different places where there's a y-intercept. Sometimes there is an x-intercept in the graph as well. In this top one, it would have been somewhere here on the negative side, but there will be always a y and x-intercept. Then they're not going to ask you to draw the graph, but they might give you a few different graphs and ask you which one is which. Then the other thing is that we want to look at the slope. So the slope of the graph is nearly going to be, and we can look at it this way, it's going to be the difference in that y number and that y number. So that difference divided by this difference. So we will look at the example, but basically the 1 point minus the other y point divided by the 2x points. I will, if there's not an example, I will create an example for us to look at. And then there's some special cases that we will also look at. So example, if the b is 0, then we have a straight line. If the a is 0, or sorry, if a b is 0, the line will go through the origin. If the a is 0, it will be a straight line going through the y. If it is parallel to the y-axis, those two are exactly the same. And then if two lines are parallel, we know that the slope is the same. So there's a few things that we will look at there's a few things that you will need to remember. The most important one is probably when we talk about parallel lines, that we always know that the slope will be similar. So they might give you the slope of a 1, tell you it's parallel lines, then you actually know what the slope is for the second line. Hopefully I have some examples of that in here as well. Once again, they can't ask you to draw anything, but they can ask you to look at certain things. So let's look at the first example. So this is nearly going to look at if we know which coordinates is in which places. So let's look at just a few things. So the coordinate system is divided into 4 areas. We have talked about it in the previous one. So those 4 areas is called quadrants. Why quadrants? Because this area is divided into 4 areas. Okay, so it's divided into quarters. So that is why it's called quadrants. This will be quadrant 1. This will be quadrant 2. This will be quadrant 3. And this will be quadrant 4. So that is how it would look like. It might be that in some textbooks they still use the Roman numbers, else it might just be 1, 2, 3, and 4. So I'm basically just showing you both that might be in different textbooks, different articles on YouTube, or if you Google it, they might just give it in different formats. So whenever you look at the quadrants, it can be in the normal numbers, or they want to sometimes represent it in the Roman numbers. So those 4 areas are called quadrants. The coordinate or coordinate system is created by the what and what axis. So again, always if you look at this type of where it's linear or even quadratic, we will always look at the x and the y axis. It might be that sometimes they give you, and now you sometimes when you look at some of the economics, and if you add some of the other subjects, they might sometimes also add here Q and P for quantity and price. So just if there is sometimes, again, if you Google, and it might be sometimes that the two lines or axes are Q and P, because when it is looking at the economics and we look at price and quantity for demand and supply. So it might be sometimes that we look at that. And then also, if we look at coordinates, coordinates are always X and Y. In quadrant 1, X and Y is positive. In quadrant 2, as you can see, the X is negative, but the Y stays positive. So everything above that, the Y is always positive. Then quadrant 3, the X is negative and your Y is negative. And then in quadrant 4, your X is positive and your Y is negative. Okay, so The reason also showing that is because they can ask you more likely what we have in E, and that is they can give you a few plots and they can ask you which one is incorrect. So they can say, let's put here minus, they could have said point A, minus 3 and 2, but actually minus 3 and 2 is sitting there. Okay, so they might just give you a couple of these points and the reference might be wrong. So that is again why it's important nearly, because here that one would have been minus 2 and 3, so very close. So if you didn't know that X is first and Y is second, you might have plotted it wrong. Okay, so again, very important to look at the X, Y, and then plot it accordingly. So let's look at those 5 or 6 plots, but we just quickly go through it so that if you guys get something like that, we find to do it. So minus 3 and 2, X for Y minus 1, X for Y minus 1. So that will be plot B. C, so minus 1 is X, Y is 0. Remember that is 0 for Y, 0 for X, so that is point C. So very sneaky the 0, because one's sometimes forget where that is on your diagram. So the same X0 is also on that point, and then Y minus 3 is there, so that will be point D. Minus 1.5, so we will need to guess a bit. So that is around minus 1.5, and then minus 2. So that will be nearly where E will be. And then point F, both is positive, so we will look at quadrant 1, plus 5, plus 3. So that will be our point F. So they could have given a few plots with numbers next to it and ask which one is incorrect or which one is correct, which one is in quadrant 1, which one is in quadrant 3. So they can nearly phrase that question in that sense instead of asking you to draw the plots, because again, online multiple choice, they can't ask you to draw anything online like that. Okay. Again, the answers are there for some of the other questions as well. So let's then go into another one that they can ask you. So, and normally there is 4 options or 5 options, but here they give you the straight line and they ask you which one of the following represents the graph. Okay, so let's just go back to the definition slide. Sorry, I just want to see, where did we do that? Okay, so the first thing I normally look at is to see the y-intercept. So y-intercept is 3. Okay, so then I will look at options on this. So, okay, that's 1, so it's not free. So I can actually say that line is wrong. Y, that's 4, not free. So I can already say that one is wrong. Y, free, Y. Okay, so that one is correct. Normally there's more options, so it might have been, let's add another one. So let's say there was a 1 that goes through 3, as in that instance, and it goes through 1. So that we still don't know yet if we have the right one, so that we need to work out the other options. So what I would do in this instance, so we have a formula equal to 3 minus x. So what I will do is say, okay, but let's put in that point. We know it's 3. So let's put in the point 3 and see then what that point is. So we assume it is 0, but let's work it out. So if I put in x is equal to 3, what do we get? Okay, so if I put in x is equal to 3, 3 minus 3 is 0, and I can then see, yes, it is 0 because it is on that line, so that point is correct. If I put in the point 1, so let's say I didn't know if this one was right or not. So let's do that. So if it was 3 minus 1, then my y should have been 2. So my y should have then actually be somewhere there. It is not. So that is why that one is also incorrect. So one can nearly check it firstly with the y-intercept, and then you can replace one of the numbers to see if the y that I get is also correct. We could have included the 3 of the y as well. So let's quickly do that, but we can just show the other way around. So my formula is still the same. It's y equal to 3 minus x. So if we set, okay, well, let's look at, it should be y, 3, and 0. So if we set y is equal to 3, again, to get rid of 3 on this side, we will subtract on both sides with 3. So both sides 3 minus 3. So we will actually get that x or minus x is 0. So it doesn't matter if it's minus x or x. And we can also then see, well, yes, that would have been also where x is 0. So one can look at it from putting in that point or putting in that point to get your other value. We would have been able to do the same with that point, which is 1 and 2. So if we have done that, again, we could have looked at x is 1. So 3 minus 1 is 2, and we see it is 2. So again, there's a few ways that you can nearly test if this is the right line for that formula. Okay. Another way was to not look at the diagram at the start and said, but okay, let's we still have a 3, but imagine there was another one with 3, then we could have just said, okay, but not looking at the numbers, let's say, what if x was 4? Okay, so 3 minus 4. So y 3 minus 4 is equal to -1. Let's see where x was 4. There we see y is -1. Okay, so we could have also just looked at the formula and replaced any other number on that straight line, or not even a number. We could have just included a number and look at it if it is actually one of the points. Okay, they love to ask that you need to look at a formula and then they represent it on a diagram. So they really love to ask that. So something like this will definitely be somewhere part of your assignments and part of your exam. They really love to ask that. Okay. Then another thing that they love to ask is, and let's take this bottom part away. So let me quickly see if I can crop it. And then we can look at it. So they give you a straight line. You can see that straight line is not in the normal way. So we normally want something to be equal to mx plus c. In some, again, areas, you will get that they call it y is ax plus b. So again, if you Google straight lines, that might be the one formula, but it might also be y is equal to ax plus b. So there might be a few different formulas when you start Googling straight lines and equations of straight lines. So just again, these two represent exactly the same thing. So it doesn't matter if I ask it in the format y is equal to ax or ax plus b, or y is equal to mx plus c. So yeah, they usually reference both of those two. Okay, so now they've given you a straight line, but not in the simplest format. And they ask you, write down the equation of a straight line that is parallel to this one, passing through a point. Okay, so let's first rewrite this equation so that we can see what it is when we look at it from the y equal to mx plus c or y equal ax plus b. Okay, so to isolate y, we will need to divide everything by 2. So then the format will be y, because 2 divided by 2 will give you 1. So 5x divided by 2, so 5 over 2x plus 7 over 2 for the b. Okay, so that would have been my straight line equation for that. What they're asking us is to tell us, okay, give a straight line that goes through this point. Okay, so what do we know about a straight line that is parallel to this one? is that your slope is similar. Okay, so your slope is similar. Okay, we don't know anything about the rest yet, but we know that the slope is similar. Okay, so we then have a formula y is equal to 5 over 2x plus c, because we don't know what the y cutoff is yet. We will only see that when we work it out. So we now need to nearly substitute the y and the x numbers, because we have it. We've got x is equal to 0. And we've got the y is equal to minus 3.5. Okay, so 5 over 2 times 0 is 0. So we will have that the c is minus 3.5. So then we have a c. So then your formula that is parallel to that one is y is equal to 5 over 2 x minus 3.5. Okay, so let's quickly draw that. It's an interesting one. So let's just put in a slide and just quickly see if we can draw that and see how it will look. So the one is minus 3.5, and the other one was, what was that? Basically 3.5. Okay, so what we have is the one will go, and let's see if both is positive. The one will go there through 3.5, and then parallel to that, there will be another one that is going there through minus 3.5. So that will be nearly how the two lines will look like. We know the slopes are similar, so they will look the same. The only difference is where they do the y cutoff. Okay, so that is the only difference. So again, here they tell you exactly how to do it. Again, they will not be able to ask you to draw the two lines, but if they wanted to do a visual representation and you needed to work out something from there, this is how roughly the two lines will look like. Okay, but every time I will, when I share this presentation with you on the group, I will share all the answers with you as well, that you have it. So don't worry that you won't get the answers to work through again. I will share that on the WhatsApp group, and then also when I load it up on my the portal on Western Cape, I will actually load this one on with some of the workings on it as well. So if you want to get access to it again later on, you can get it via the the Western Cape portal as well. Okay, so just a quick stop at this point to get a check-in. But while we also do a check-in, I am just putting in again the link to our WhatsApp group. And if you can't get to that WhatsApp group via the link, my number is 0837908387. You can just send me a WhatsApp and I will add you to the group. Okay, quick check-in. Is it okay still? Can we continue? Is there things that I need to go back to? Just want to get a check-in on how you guys feel this chapter is going. And the thumbs up is also fine if everything is okay till now. I don't know if there's a thumbs down. So if there is issues, do the surprise um, emoji or something like that. Then I know we need to relook something else we will continue. Okay, cool. So let's continue. So this again is a question that they might ask because it's a way in how they test some of the definitions without asking definitions. Also for you to, again, let's be honest, you're online when you're doing this, it's easy to Google something. So if I ask you one definition question, it's in a sense easy to Google it. If I said, what's the definition of the function or something like that? But here they're asking you 5 things about straight lines. So it's a bit more difficult or not difficult, but it takes time. So if you pressed for time, it does take a bit longer to get to the answer. So let's look at this and see which one matches up. So 2 lines that are parallel. So we have seen 2 lines that are parallel. The slopes of the 2 lines are equal. So let's look at one line has a positive slope while the other has a negative. So not that. Expression is y equal to b. Okay, not that. There is no constant. Not that. Expression is x equal to c. Not that. Both lines have the same slope. Okay, so for the first one, we know it is e, and we can take that one out. Okay, so let's look at a straight line that passes through the origin. Okay, so let's quickly, a straight line that passes through the origin. So if it passes through the origin, your C is equal to 0. So you will basically not have a Y cutoff because it will be 0. Okay, so there's 4 options left. So let's look at the first one. One line has a positive slope while the other has negative. Okay, we're only working with one line. So the expression is y equal to b, where b is the intercept. Okay, no. There is no constant term b in the value equation. So again, here now they're referencing that formula, the y ax plus b, where b is the intercept. So let's look, there is no constant term b in the equation because it's 0. So that is the right one. So again, just let me just write the other one as well, the mx plus c, because it might be that they look at both. So now here you can see that they use c. So they sometimes use the one in the one term and then the other one in the other term, which makes it sometimes a bit confusing, because you want nearly them to use one formula straight through for all the options. A line that is parallel to the x-axis. So let's look at that. So that's the x-axis. So a line that is parallel to that. Okay. So let's look at the options that's left. Okay, so again, that is looking at two lines, so it can only be B or D. The expression is y equals to b, where b is the intercept. Okay, that is true. Expression is x equal to c, where c is the intercept on the x-axis. Not true because it goes through the y-axis. So option or question 3 goes with option B. Okay, so we take that out of the equation. Two lines that intersect at the origin. One line has a positive slope while the other has a negative slope. Okay, so that is that, but let me quickly show you that in a diagram. So if we were drawing the x and y, so if you look at it, the two lines that crosses in the intercept. So two lines that intersect at the origin. One line has a positive slope while the other has a negative slope. So we can see that that one has a positive slope. This one has a negative slope, and it goes through where b is equal to 0. Okay, and then the last one must be equal to d. But again, let's align parallel to the y-axis. So let's draw that as well. And let's now use it. So a line parallel to the y-axis. It can go there through x, that's a negative, or it could go there through x, that is a positive. So they tell us a line parallel to the y-axis, the expression is x is equal to c, where c is the intercept on the x-axis. And there you can see that c will be the intercept on the x-axis. Okay, so that is nearly looking at all the possibilities that can happen in a straight line. So you've got the one that is parallel so that the slopes are the same. You've got the one that is parallel to the x-axis, and then the one that is parallel to the y-axis. And then you've got the one that goes through somewhere in the intersection where it is 0, so that the origin is 0. So that is nearly the different ways that they can ask you in a question. So nearly again, and I'm just adding it so that we can just quickly see it, is that all the options summarized into one. So you can have that one that is parallel to the y-axis. You can have that one that is parallel to the x-axis. You can have the one that goes through the intercept, so where that is 0. And then you can have, so we can even say, okay, let's look at those two that are parallel to one another, where the slope will be the same. Okay, so that is nearly what we have covered up until now with straight lines. So then the next section, moving on from straight lines, is that we now look at quadratic functions. And basically, the other name for quadratic function is parabola. So again, if you Google and you want to get extra YouTube videos, you can Google all quadratic functions. You can Google parabola. That will give you some extra things that you can look at. There's always very nice YouTube videos on this and explaining it as well. But let's go through a few things like we did with the straight line. There's a few characteristics of the quadratic function. So the first thing about the quadratic function is there needs to be a x to the power of 2. Okay, so that is the first thing that is extra. Now you can see once again, there's a A, there's a B, and a C. So we will reference sometimes to those three in questions as well. So they could tell you in a question, you're working with a quadratic function, A is equal to this, B is equal to this, C is equal to this. Which of the following graphs are the correct one? And then give you 4 or 5 options of graphs as well. So we will look at an example of that for you as well. So that is how the straight line will look like, how it is mathematically written. The shape of, oh, sorry, not the straight line of a parabola. The shape of a graph, you can see it is in that format. It does not need to be around the y or x axis. It could be here as well. It does not need to touch that x axis. It could be there as well. So with a turning point, it might be somewhere here as well with a turning point. So these are now perfect parabolas that were drawn, but it might look a bit differently as well. So it not always this nice looking parabola. So then what is also important is we will need to work out that turning point. That turning point will be worked out with a formula of minus b over 2a. So that is that b and that a. So whatever those values are, we can just substitute it into that formula and we will get the turning point. And then they can ask you to work out the x-axis. So let's say it wasn't, let's say it was maybe something like that. So we would have had a turning point there, and then we would have had our two x-axes that we will work out with this formula. Okay, so that is how we would work out the x-axis, and the turning point is via those two equations. Again, they will probably not ask you everything in one question, so they might give you the equation and say what is the turning point and what is the intercepts of the x-axis. They might give you the turning point and the x-axis, and you need to rewrite it into the formula. So there's a few ways that they can ask you to do it. So let's look at a formula, and we nearly go step by step to analyze it and break it into its components. Okay, so here they give us the formula just as was given in the previous. So they tell us it's the normal formula of ax to the power of 2 plus bx plus c. And we will now need to solve the different equations by reading off the graph. So I like to look at the y-intercept first. So we see that that is 5. Okay, so we have a c value already there if needed later on in the questions. Then they ask us what are the intercepts of the x-axis. So the one is x minus 5. And the other one is x minus 1. Then they ask us, what is the value of the x at the vertex? Sure. Okay. Haven't heard that term in quite a while. So if you Google vertex, you will see that, and let's quickly Google it, because I would have said that is where it's the turning point. So let's look at what is vertex. Vertex is a point where two line segments meet at a sharp angle, or where two curved lines meet in a parabola. So let's rather go to images. So that turning point is the vertex. Really have not heard about that word for quite some time. So again, if you get a word like that, Google to see what it is. But basically, they want to know what is the x value at the turning point. And the x value at the turning point is equal to minus 3. Okay, so now they are going to ask us a few other things. So they've now nearly worked it from the way that they haven't given you a formula. They just given you the basic formula that there are. And you now need to see at point E, you will actually need to complete some of those formulas. So let's first see what is the minimum value of this function. So what would you guys say is the minimum value of this function? and you can put it in the chat. So what is the minimum that this function could go to? Okay, so minimum. So let's look at just again. Sorry, why did that now show? I just want to. Okay, so remember minimum is of a function is your y. So the minimum value that it can be is at that turning point. So the minimum value that it can be is -4. If it was the other way around, we would have had a maximum. So remember, if the arms is going up, we will have a minimum. If the arms is going down, we will have a maximum. When the arms is going up, your A will be positive. When the arms is going down, your A will be negative. Okay, so that is also something that we will now look at by completing some of the points within this formula. Okay, so in the function formula, fxa is the value of a positive or negative. Don't calculate, look at the shape. Okay, so we actually now have answered it. So because it's going upwards, it is positive. We are now also going to, and they don't ask it, but we are actually going to, I'm going to show you how to calculate the original formula as well. And then just let's look at the last one. If a value of a discriminant b to the power of 2 minus 4ac greater than 0, less than 0, or equal to 0, again, don't calculate. So what this refers to is, and let's quickly look, have we done it in the previous one? We actually have not. So it's looking at this function. Okay, so if you look at that, and you see that you have 2x values, it means that that must be positive, because if it's 0, you will be heading to that point. If it's negative, you can't have a square root of a negative, so then it will be something like that, because you won't be able to get the square root. So by just looking at this, and because those two are actually numbers that shows that it goes through the x's, we will know that the b squared minus 4ac is going to be bigger than 0. Okay, so again, if we look at this, we can get it in the answer set as well. They explain it more in detail, but basically, if you look at this formula, and you look at it, so if it's 0, those two are exactly the same. So if it is 0, that will be the point that it goes through. Or not that point, but it will be at the similar point on the axis, because that is 0. Okay, so if it is negative, it will be up in the air because you can't have a negative under the square root, so it will actually be non-valid. So the only way we can look at it with this graph is to say that it is going to be a positive number. Okay, so it's going to be bigger than 0. So let's work out this formula. So let's quickly work it out, because it might be at some stage you get a question where they give some of the information to you. So let's just copy this over and then let's work it out. Okay, so we now have the following information. So we know that the Y cutoff is 5. So at least we know that the formula is, so that is already one of them. Then we know there's a -5 there. There's a 1. So how we do that is then to say, and now this takes you back to algebra and the maths that you might have had at school. So we basically getting 2 points. So the answer would have been if x minus something, so let's rather do it this way. X minus something would have been equal to -5 for that. Sorry, for that one. And this one would have been x minus something will be equal to -1. Okay, so that is how if we go back to your maths from high school or algebra that you did at some point, that is how it would look like. Okay, so then to solve that, we would just say, well, that is equal to 5 and that is equal to 1. Okay, so x plus 5, so I said that, because x plus 5 would be equal to 0 when x is equal to -5. So I just tried it now to work it from the other side around. So this one will then be x plus 1. So let's multiply that in. That's x to the power of 2. That is x. That is plus 5x. And that is plus 5. And now we can see that that is at least the same. So we know that we have been working right, but we're going to check a few other things as well. So I want to show you one or two other things with this as well. Okay, so then we've got the final one is x squared plus 6x plus 5. Okay, so that is our formula, but let's just check a few things. So we have looked at the turning point. So remember, we set the formula for the turning point. Where was it? Minus b over 2a. So let's see, is that turning point minus b over 2a? So b is 6, so minus b over 2a, a is 1, so minus 6 divided by 2 is minus 3. Okay, turning point is at minus 3. So we have checked it against one of the variables or the formulas, and it works. Okay, so you can actually go and check if you put it now into these formulas, you will get that for one x is going to minus 5, and for other x is going to be minus 1. So that will be a nice nearly exercise to also check for you if that corresponds. Okay, so again, they haven't asked it in this question, but I wanted to show you guys, if I give you a picture like this, yes, they've asked a few questions that you need to derive from it, but they can also ask you to get the final formula as well. Okay, so that is one of the ways to get to the formula with this information. Okay, again, I will share the video so that you guys can go through that process again, and I can show it next time as well. Okay, other formulas that is in here that I don't like at all. So it is the last two. So we'll look at exponential functions and log functions. So basically, again, there's a few things that I now have put here together. But if I want to ask a definition on exponential function, it will be that it doesn't matter how your formula looks like, it will never cross that x-axis. So there might be negative ones as well. So don't get me wrong, it doesn't always all be up in quadrant 1 and 2. There can be ones in the negative as well, but it will never cross the x-axis. So that will never happen. So it might be that it runs very close to it, but it will never cross the x-axis. Okay, so that is one that if I ask a definition, I love to ask that, because it is sometimes a nice one to have a few graphs on it and ask which one is correct and incorrect. They didn't even need to tell you why. So they could have had something like this. They could have had, that is your one exponential. They could have done another exponential like that. They could have your linear equations, and then they can ask you which line is not correct or something like that, so that you must know that that one never crosses. So that is something that they can ask you in a sense if they want to draw lines, and not ask it in a pure definition type of question. Okay, then the other thing is that really important to look at that formula. Um, Again, certain things in that formula. So again, the b always bigger than 0. So you can't have a negative. Then it is not an exponential function anymore. Then you will go into different functions. And the other thing, the a can be negative. It can be a fraction. Um, so it does not need to be only a number like a whole number or anything like that. The same with the x. It can be something to the power of a half, but very seldom it is something like that. So again, they could, instead of showing you it on a graph, they could have said, here are 4 exponential functions, which one is incorrect? And they could have added a one that is 0. And say something like that. They could have, and they could have maybe drawn it as something like that. So that you think, oh, okay, there it goes through -1. It's fine. It is correct. Or put in the minus in front and confuse you. So that is another way that they can do it, is by giving you 4 equations and asking you which is the wrong equation. Okay. It's very difficult to nearly ask this any other way. So what I've now done is nearly, yes, just to show you how we draw it. So this is more for you to get that visual picture, but this is not something that they can ask you in an assignment or in a test, because again, multiple choice, it's not on paper that you need to write anything down. They don't have the technology to ask this, that you draw it online. So something like that will not happen. This is more that I can show you how some of those numbers pan out. So you can see X values here. That is interesting. We just said that. Oh, sorry, not X. I said X must be. Okay, sorry. So that was a fault of mine. It's actually B that can't be smaller than 0, not X. Okay, so how would that line look like? So let me quickly take that out. I need to think how a minus X, so we will see now how that will look like. Let's just look at that formula again. Okay, so it's the value of X. So again, we're not showing. We're not doing this. Okay, so the value of X can be negative, but not in the formula. Okay, so again, they can't give you this formula, the formula always needs to be in a positive tone. Okay, so that is the difference. Sorry about that. I know I made a mistake on how that can be written. But so you can always have a x value that is negative. It will still not cross the x, but you don't write it as a negative x. So let's look at this. So if I put x as 0, 2 to the power of 0 is always 1. So anything to the power of 0 is 1. I think we did it in the previous chapter. So anything to the power of 0 is 1. Let's look at the other ones. Plus 1, so 2 to the power of 1 is 2. So where x is 1, y will be 2. Where x is 2, y will be, let's guess that is 4. Where x is minus 1, 2 to the power of minus 1 is a half. So where x is minus 1, it will be a half. So let's take where x is minus 100, just as an example. So if you go to your calculators and put that into your calculators, you will see that's still positive, but it's like to the power like that, or a very, so where it is here, it will be still positive, but it's just above the line. So again, showing that it will never cross that x-axis. The same if it was a minus in front, then the function will just, now look like that. Let's quickly see if it was 1, 2 to the power of 1 is 2, then it will be minus 2. So, sorry, it will be minus 2. That would have been where x is equal to 0, it will be equal to minus 0. Okay, so when you look at this, in both instances, it can't cross that. So that's the most important one about exponential functions, is that it will never cross that x-axis. Okay, so then we go into, and there's just the example of it that we have done. Now we look at the log function. So now what do you see about the log function? Is that when you work with log, there again, it will never cross the y-axis. So that is nearly the two differences between this. The exponential one will never cross. So that one was wrong again. It will never cross the x-axis. Log function looks a bit different, and it then goes along this line. Okay, the thing that might change, but you guys don't do it. So that's why I must actually not mention it, but let's just let's add it just so that you, because I don't think they will do it, but if you had, so if you look at that function, it does not cross the x-axis. If you look at this function, it does not cross, but in this instance, so look at that. If we put in that same function and we add a constant, then it will move accordingly through that constant. So that's the only time a log function can go through the y-axis is if there is a constant added to the function. You guys don't need to do it. So that's why I didn't want to add it. But if you guys Google log functions, you will see that some of them goes through the y-axis, and that is because there is a constant added to it. So that basically moves the line on that y-axis. So that is the only time that it will actually go through, because then it moves it on that line. So again, you guys don't need to worry about it. It's not part of your work. But if you Google log functions, you might see very weird log functions popping up again. And it's not because you need to know them. It is just different differences when it comes to that added C that might be in some of our other subjects that one is doing, but you don't need to worry about that. It's not covered in your work. So what they sometimes also do is, and I will add that to next week's session, or I'll see if I've got examples of that, is actually not that you nearly look at this, but they give you that you need to work out what is log 721 or something like that. So they're not really going to ask you to write it down. They're not really going to look at it from this point of view to ask definitions, but they can ask you y equal to log 721. Choose A, B, C, and D as the correct one. Okay, so then you can look at this and say, okay, well, A is 7, Y is there, 21 is there. Okay, so let's get one that actually can work out. Okay, so let's look at log 2 of 8. Okay, so you will then have 8 is equal to 2y. So then you need to work out what is y. So 2 to the power of what is 8? So 2 times 2 times 2 gives you 8. So y would have been, in this instance, have been, sorry, 3. So 2 to the power of 3 will give you 8. So that previous one of 21 and 7, obviously they won't give you those kind of options. It will be more the ones that you will be able to work out. Okay, so that is something that they can ask you in your assignments and in the exam. Another thing is if they, and here they now said, but showed, but if I just show you log of x, that then actually means log 10 of x. So on your calculators as well, if you get log of x or ln of x, that is actually log 10 of x. So that is the standard. Okay, so they might not always show it with 10, but if they show another number, then you use the other number. Otherwise, they can log 10 of x is exactly the same as log of x. So just again, if you guys Google something and you see it, that is why sometimes it looks differently, because that is exactly the same. Okay, so log 10 of x is exactly the same as log of x. It's part of a definition nearly, so it's not that it is something else that suddenly we now it need to know. It is just part of the definitions and how the maths was set up. It is definitely not something that you would get in a different. So they will always tell you, or there's nothing, or there's a 10. Okay. Okay, so that is this section for tonight. So we basically, let me just do a recap. So we basically have looked at functions, but we have looked at linear functions. We've looked at quadratic function. That's the ones that they will focus on in most of the test and the exam. That is the ones that they will focus on. If there is something in the exam or in the test, in the assignments on exponential and log functions, it will most likely be in the case where they look at something like this, where they ask you to solve it. The same nearly for the exponential functions. It might be that they ask you rather to solve it or tell you that something like that. And they ask you which one is the value of x. Okay, so that is how they would nearly do it with the exponential and the log functions. They will not really give it in a different format. Okay. Questions on this? I'm going to share the presentation. I am going to send you the recording as well so that you can look at it. So let me quickly mute any questions. I know we've quickly went through this tonight. So I will load this up on YouTube. I will share the link for you guys on the WhatsApp group. Bronwyn will, in the next 2 or 3 days, will also upload it again to the chat like last time. So it will be there for you guys to look at as well. Okay, let me stop the recording.